Welcome everyone. Today we're going to discuss about 3D map. We have our world famous professor, Professor David Smith. I think he is very knowledgeable. He always share his knowledge on many complex topics. So I think today's topic is very new for our audience. Professor David Smith, what you want to share and what you want to add for today's session?
Well, Sharif, thank you. This is a topic that has many different ways it can go and many different outcomes. Let's just start with the beginning of saying what is 3D mapping. And 3D mapping really means what you're doing is you're profiling objects in 3 dimensions and trying to map them in the real world. And you can do it with many different ways. You can create this in real time. You can do this with software modeling and simulation. And it really makes a difference as you're beginning to look at precision. Um, the most of us, as we saw maps and stuff growing up, we went ahead and we understood that they were 2 dimensions. Uh, and the dimensions really were, X and Y. And what we begin to do is we add 3 dimensions to it. We're beginning to add X, Y, Z. And what we're seeing as we go further on them, you were seeing that we are um, really beginning to look at what are the dimensions that we need to work in detail. What are we beginning to do with things where we need the science to work more, where we need to begin to understand the other elements which we can bring to it. So we see 3rd dimensions, we see really 4th and 5th dimensions as we begin to add more elements like time into our equations. And the 3 dimension world is one that with manufacturing you have to do today as you look at where we're going with computer building and other elements like that. Uh, One of the advantages of 3D mapping is it provides the really some of the best ways for visualizing and gathering information and knowledge and science visualization and mapping becomes easier when a 3D map is available. We now have applications everywhere on the internet that we can begin to see 3D maps of the world. But we're increasingly seeing using 3D mapping and modeling combined, the use of 3D maps in things like architecture. Today, if I want to buy a new house, oftentimes the architects have generated a 3D map of the house that I can walk through and not just see the lines flat in a 2D representation, but I can see them in a 3 dimension. We've talked in the past where augmented reality can be combined in things where, for example, at a factory being built, you have the factory modeled in 3D. Then you go ahead and put the equipment and other things there in 3D. But then the installer of, let's say, electrical outlets for a piece of equipment or pneumatic air or other things, can take those 3D models, see them in his augmented reality goggles, and then go in there into the physical place, which is superimposed with the 3D model, and actually be much faster in solving problems and doing installations than you could without that type of approach. Um, and you're beginning to see 3D used increasingly everywhere. Google Earth, the street view is a 3D view of what you're seeing from the either the plane mapping view or some of the others to get you more detail as you're doing it. One of the places where 3D mapping has really taken off over just the last 2 years is in the drone industry. Uh, the construction industry started going digital probably 15 years ago, and really has picked up speed going it. Um, Now you walk into, for example, a construction office or an architect's office, and you see desktop computers and tablets instead of drafting tables. And you're seeing them producing 3D mapping rather than using roll and rolls of blueprints, and it's not there. So let's just step back and look at the market on this a minute. 3D mapping in 2020 was about a $13 billion marketplace. However, this is growing with a compound annual growth rate of about 22% a year. So you're seeing that type of growth as this becomes more accepted. Um, and what we've seen with this digitalization of the 3D mapping is it's enabled industries to reduce costs and time, which helps you become not only more efficient, produce more revenues, but it also lets you become more creative with what you're trying to do because of this 3D model. And 3D mapping is a direct application of 3D modeling technology, and it can be used. So you have to have the data, you have to have the different points. One of the technologies that is used very often in 3D mapping is 3D laser scanning. So it's using a form of LiDAR, and so instead of a tape measure and levels, the laser actually scans to capture all the angles, the levels, the distances, and it can be done very fast. Uh, like I started as saying earlier, drones are doing a lot of surveying now where they are actually producing these 3D maps, these 3D models as they fly over the area. And this can be in a construction project, it can be a field doing agriculture, it can be a model inside of a building that they're beginning to go and remodel and construct. It could be a 3D model for the military or for industrial planning. And that's a lot of where we see some of the early usage of 3D technology today. Um, and you see it really being important because it's letting us look differently about how to market, how to construct, how to design, and all of the different elements there. Um, the early parts of 3D mapping were really done with a 2D image and then using lights and other things to get that. The early days of, for example, AutoCAD, when they began to start moving towards 3D, it was mostly lights. It's gone really well beyond that now because it takes now into more accounts geometry, its position in space, its construction either, and what are the unique things that are uh, being produced around the object. Um, but going back just a little bit, back in 1969 is one of the first places where we saw 3D mapping exposed to the general public. Um, Back in 69 at Disneyland, there was a new attraction called a Haunted Manor, which was a projected 3D model on a complex surface. And it brought these 3D objects to life as they're waiting. And then you begin to see it going in today. Then we begin to do things like you've heard digital twins and others, and often those are in 3D. Um, what we also began to see is that in the 90s, video mapping began to come alive. And that's when we saw 3D maps being generated to use in planning and looking at routes, at how to build highways and other elements like that. And it was one where a lot of progress has been made. Um, and today we're seeing it, like I said, used in new and very different ways. Uh, for example, we're seeing it used in places where 3D mapping using 3D printing is being used to, for example, uh, make decorations that can be used. It's being used to build houses. It's being used to build replacement parts for things ranging from cars to tools to airplanes to even it's being used on the International Space Station to generate parts that can be used there. And this 3D mapping is actually beginning to be used considerably even in the advertising industry because it lets you begin to take a lot of speed and speed of innovation back to your clients. And it's being used, for example, at a lot of opening and closing ceremonies for sports events, championships, and others. We saw some 3D mapping being used as part of the opening ceremonies around the World Cup. And we've seen it used at Olympics open and closing ceremonies. And now we're beginning to see it in an advertising mode being used in cafes and restaurants. And it's a way to help showcase what's there. Also, kind of taking 3D mapping and pulling back even further, we're seeing the application of 3D mapping a lot in healthcare today. And I can build, for example, a model of DNA and RNA and the interactions of it. But when you begin to take a 3D map of those, and for example, begin to apply the interactions from the COVID vaccines on them, or the interactions from how the blood reacts to different things, that mapping really helps you understand it more in 3D. For decades, we have been making 3D maps of underground oil formations so that we can see where to drill, how much oil is in it, how much natural gas is in it, other elements like that, as we build these 3D mapping models from the seismic data that we can pull and use. So again, a lot of very various applications there. Um, there's beginning to be more put together around 3D projection. And 3D projection, we many of us are also knowing today is holographic projection. And we're beginning to be able to build out of these 3D maps now these 3D models, increasing more holographic displays. And you have to really understand the measurements, the processes, the other elements of how you can structure all this together. And in the industry, they call it stitching together to put the 3D map in place. And there's just growing interest all the way around now. There's some sites, one of them that I had gone to not before is called newweathermaps.com, which is very interesting because what they've done is they've digitized the world in 3D. And then they are taking these 3D models and letting you overlay in 3D again things like wind, rain, other types of weather. They're letting you put radar images on top of the 3D images. And this is a site that anybody can go and access today. Um, and the big growth of GIS systems, geographical information systems, have further stepped up the movement towards 3D mapping. You heard me mention earlier AutoCAD, and AutoCAD is all in 3D now. But also, if you go into things like Esri's ArcGIS, ArcGIS has a scene viewer and has 3D inbuilt capabilities now, and you can begin to build it. You see places where some of the IBM software and others is beginning to go there. But what is very interesting is Microsoft Excel now has the ability to let us do 3D maps of our data in Microsoft Excel. And the Z component of this really helps us understand some of the nuances in the data and how it can be used. That is why you're seeing this type of elements used so much in visualization. Is it lets you see the extra details there and what it's good, what's happening, and the elements really are such that you need this type of references to be there, because just XYZ's there. The other one we're seeing move into 3D mapping is actually a fourth dimension of time. So you have XYZ and you have delta T, which is how it changes over time. And as you do that, it will let you again represent more and more detail, more and more what goes. And we're beginning to see even other dimensions begin to be used in it. Einstein really went back uh, in his early theoretical work, said it's not only one dimension, two dimension, three dimension, four dimension time, but there's a fifth dimension as well. And in Einstein's work, this fifth dimension was really around gravity and its effect of gravity. And if you can see that as you look at the XYZ and changes over time, that the fifth dimension can have an impact as well. But 3D mapping is one that we should see heavy utilization and training today in the academic environment. So if you always ask about what is the impact on colleges and universities and trade schools, and there should be a high impact. There's no need to do things the way we did in the past. I finally, a few years ago, gave my drafting table away and gave my tools I used with it. I no longer have a 45-degree triangle or a 90-degree, 90 degree triangle, because we're doing everything digitally. Governments should be fully embracing the capabilities of 3D maps. It can be used for permitting. It can be used for planning. It can be used for urban planning, for rural planning. It can let you bring a new dimension of saying, I've produced this 3D map. I now want to go from a 2-lane highway to a 6-lane highway. Let me lay it in that map, and how can it have an impact? Gee, I want to build a 100-meter square building here. How will that impact it? I'm going to do a manufacturing process, and it's going to have runoff because of the huge parking lot when it rains. Let me do a 3D map and see how that runoff can affect the environment around it. And the use of 3D maps when you look at environmental, particularly in sustainable environment, gives us the tools to begin to do some of the modeling and simulation that we spoke about when we were talking about the COP27 impacts last week, because you need the data to be able to drive the information, to have the knowledge and wisdom to make change. And the use of 3D maps are one that can do a lot for that, to help predict it, informing it. And the impacts is just so great. Um, I could keep going multiple directions, but Sharif, is this kind of where you'd like us to go?
Sure, Professor. This is very interesting discussion. I think it will be helpful for our youth communities, those who actually regularly share and use our content for research and innovation purpose. And you will be happy that Uh, we are also sharing our content with many social entrepreneurs. So it will be a very interesting session for them. At least they can understand the new topic, which is not this kind of topic is not available in emerging economy.
Okay. But as you begin to look at the whole way of the 3D map, you can really understand its impact in the entrepreneur community too. Uh, there's another website that is interesting besides Google Earth, which is the one I tend to use most. There's another one called Earth 3D Map. And Earth 3D Map is another one which is very interesting as you look at how it can be used. Um, so if I just begin to think about how it can be used, let me see if I can begin to give you a model of that. Um, you can go ahead and, for example, go into Bangladesh, Abanka, and begin to see the nuances around it. You can look at where in 3D models the international airport is in relationship to the others. You can go and see from the international airport in 3D how you get down to the national parliament and the new markets and all the other elements around it and all the universities and how they can work and play in a 3D environment. And you can build it up, you can add the skyscrapers in it, you can add the other elements to make it where you can understand the environment more. So let me see if I can do this. Uh, Sharif, I'm going to try to do this, and I'm not for sure it's going to let me. Um, okay. This one's a hard one. Sometimes, Sharif, the old systems like Zoom is easier to manipulate than broadcast mediums like this one. Let's see if I can find it. It's not going to let me display this 3D model. All right, I won't try then. But I had gone ahead and pulled up and constructed a 3D model of downtown decor and was looking at the different elements in 3D and how they could be used and how you can pull them together and really work to enact change. And that's one of the places where this is being used extensively is how can I interact change in an environment? And um, it to me being able to see relationships between the elements really presents you with what you need to do. Um, I'm going to try one more time and just see if I can do this because I think your audiences will enjoy it if I can do it. This is also telling me I have way too many windows open. It's not going to let me share the browser. I don't think. Wait a minute, here we go. So Sharif, I cannot tell on the broadcast. Can you see this 3D image I'm projecting now? Sharif, I hope I'm there.
Yes, yes,
Okay,
I
so
share
if you
already.
so if you look at this image, this is in Bangkok, and you can see that with this type of imaging, you can see there's very high buildings here you can take and change your dimensions going through them. And this is a 3D map, like I said, of a free service, the earth3dmap.com, that just makes it so easy to take and use these for planning. I would look at the park here and the elements and see if I did something up here with buildings the heights that we were seeing down in the earlier part, I would block the swimming pool and things where the lights during parts of the day wouldn't be there. You can begin to look at the embassies, the other elements like this, but in 3D, you begin to see even more. And as I go down and zoom into it, like you're seeing here, you can see the nuances of what you have. And if I'm wanting to do inspections, if I'm wanting to do surveying after a disaster, uh, it is much easier for me to go and do this first and then go on the ground and do the work based around it. Uh, I almost feel with this, I could come to Bangladesh and navigate my way around, even though I haven't been in this part of the country before, just by using the 3D tools that are there to understand the differences. Um, let's come back and add a couple of more things. Um, the use of 3D maps in areas like that are pretty straightforward. But you heard me mention earlier that there are different ways to use 3D, for example, in Microsoft products. There is a Microsoft 3D Maps for Excel, which is a way to build the 3D data maps that can give you a tremendous amount of information. There's also a tool that's available in a lot of the Microsoft applications called Power Map, which is a 3D spatial visualization that can be added into it and being used. So one of the places where I have used this in Excel is taken a map of an area and projected on top of it the data built in 3 dimensions to see the impact or the density of some of the technology that's being deployed. Um, Also, there is something that you see in the drone industry, in the transportation industry, and others called beyond visual lines of sight. And this is where the 3D mapping comes so into place too, because it allows you to build a model where you're going, and so that you can use simpler tools like optical imaging or LiDAR or multispectral and navigate places where you haven't been at a distance for you. You know, you've heard about all the drones being used in the Russia-Ukraine war. They are controlled in many instances by 3D maps in the planning stages, 2D maps as they're flying to their destination, and then very often, depending on the sophistication of the drone, 3D maps as they begin to strike their targets so that they can see where they are in relationship, not just X and Y, but Z, where you can decide, I want to hit a office on the 5th floor of the building and not the top of the building, and other elements like that. So you can see in even warfare how the 3D map can give you advantage. But we're talking a lot in other programs about the use of autonomous vehicles, autonomous cars, autonomous delivery vehicles, autonomous tractors for agriculture, um, and others. And this 3D mapping, once again, is what is the enabler to let you go and use them in a manner like that. So I'm trying to think of the other places I should go. And finally, we're seeing 3D mapping used broadly in things like entertainment. I haven't seen it. I've seen the previews of the second Avatar movie, but it is all a 3D generated synthetic environment. And to generate 3D synthetic environments, you need to do the 3D mapping. You actually need to do the 4D mapping because the element of change over time is so important. And as a futurist, I think one of the things we will see heavily in the next couple of years is we will be moving very rapidly from 3D to 4D mapping as we see the growth of autonomous vehicles, as we see the growth of autonomous manufacturing with robots and others, where they need to understand not just the three dimensions, but the element of time in relationship to those. And so many of the tools that are being developed will have to have uh, the delta t, the fourth dimension in it. So, Sharif, going back to your questions with entrepreneurs, with colleges, with universities, it's important for them to begin not just in the advanced science courses, but even teaching entrepreneurship, even teaching healthcare, teaching architectural, teaching even business marketing. Because one of the things you want to do if I'm trying to judge how effective a retail establishment is to build a 3D map of it, see how it changes over time. If it's a restaurant, where do the customers go? If it's a retail store, what are the heat maps of where customers go? If I'm doing a 3D map and with time of shelves, what is causing customers to buy more from the third shelf versus the fifth shelf or the first shelf? And all those are things that you can use the data, the 3D, 4D mapping, and be able to understand. Uh, that's a lot of where I can talk easily on 3D. You can see the science is advancing to go from a very first application of 3D mapping in entertainment with Disney in 1969 to where we are today with these very advanced capabilities like the one I showed on screen of Bangladesh and Dhaka. Uh, Without that being prepared explicitly for 3D, uh, the industry's come a long ways, but there's still a long way to go. You know, to be able to take those images, move them into a digital twin, move them into a synthetic environment, be able to go from the outside going inside, seeing the inside of the structure, the building, and even to take it to the next level of take the construction diagrams and look inside the wall and see where the pipes are in 3D, to see where the electrical wires are in 3D, the other elements like that. You can see how that would give you a tremendous advantage for you adapting the digital worlds and the physical world together to become more efficient, more productive, and in many ways a lot safer. So that is part of where I see this whole 3D, and I'm going to do 3D/4D mapping because time is getting so important on everything. Um, and we're going to see that in government as well. So, Sharif, some more questions to help me uh, be more of benefit for the audience.
Yes, specifically, Professor, we are working with many entrepreneurs, especially social entrepreneur from emerging economy. So how uh, the social entrepreneurs from emerging economy they get benefit from this kind of technology, or they can introduce this kind of technology in their ecosystem? What is the procedure? How they can do that?
Well, it's pretty easy to introduce this technology into the ecosystem because there's so many open source applications of it now. If you were just to do an internet search on open source 3D mapping tools, you'll see quite a few. And you'll see applications from like Esri with ArcGIS, which have free versions as well as pro versions. you'll see Google. Google early was one of the leaders in releasing 3D mapping tools, 3D models. Uh, the original Google Maps, the original Google Earth were 2D imaging, which are both of them now have the 3D in it. And both of those now I can go ahead and put time in as a constraint on those. Let me see if I can actually do this here. I'm not for sure. I actually on my notebook have Google Earth
Mhm.
installed, and to and at what I'm trying to do, where I'm going, what are the other elements uh, you're trying to work with. And it's slow loading because there's so much detail in it today. It has been moved to a very high resolution environment. And I can, for example, with the Google mapping tool, the Google Earth tools, I can now actually go and map on the moon and do the other elements like that. And I actually just pulled up an experimental version of Google Earth. And let me see where I can go to give you an example in a minute. So I'll give you one more example and see if this can help us understand a little bit more. So I should be sharing this on the elements again. So this is Google Earth, and you see I'm running an experimental version up here. But this is the information on Sao Paulo, Brazil, a wonderful city. And if Virginia's online, she would tell you, and this is how it looks in a picture. But let me begin to go down and take the same area, and you can see how you're seeing more and more detail as you go into it. Let's see, where is it I want to go? Oh, there it is. And just looking in a very dense city like this, you can begin to see the 3D structures put in place here. But one of the more interesting things here, let me go over into this environment right here, and let me strike it here, and we go here. And I can now build the 3D model of what is I'm looking at just by zooming into it. Here's the environment. I can take and navigate down the street, down the other elements, and see exactly what's there now. And you can go and from that overhead image to the overhead 3D image, actually navigate in real time and see what's there, how I can work the elements. And you can see how this is a wonderful tool to use for planning. It's a wonderful tool to use for the other elements you have there. And then just to go from the 3D element back into a 2D and others, you lose so much insight by doing that. And the tools for the 3D, and particularly the synthesis, like you saw, the fusion, like you saw, are the elements that entrepreneurs can begin to use a lot. And particularly, Sharif, I as can use demographics, the detailed information about people, people's movements, their functions, overlay that into a 3D map and create opportunities. Should I, do I have enough traffic here to support a restaurant with 100 tables? Or does the traffic in this area only support a restaurant with 20 tables? What are the traffic flow patterns like? Um, what are my sight lines? Do I want to build a house here with a big deck on the back side of it? That when I do the 3D map, the only thing I see is the back of a manufacturing building or an apartment complex in the view, and not something that I would want to have more there. So, once again, the whole area of 3D mapping, and with time, you noticed in the Google Earth element, I was able to move down in time. I was able to see the dimensions move there. And, you saw it even had captured some of the traffic in real time, which I always love. The Google Map version of where I used to live had captured one of the images when we were having a delivery made. So you saw a piece of furniture in the satellite image in the middle of the driveway being delivered. Um, and you can capture that type of information too. Um, but as a futurist, 3D mapping, 3D imaging, 4D imaging, where you add time and changes over time, is really where the future is going. I think back when I was a young kid and all we had was paper maps and how they got places. And then we added today two-dimensional GPSs. What we're seeing more and more now is three-dimensional GPSs. So we not only see where we are on a pinpoint on a 2D map, but we see the buildings around us, we see the landscape around us, and that's helping us be more accurate. Uh, and you're going to see that driving everywhere. The examples I've been using are outside, but you can see us doing the same thing in a factory. You can see us doing the same thing in a healthcare facility. You can see us using the same technology so many different places. So that's probably, unless you have other questions, most of what I can say about 3D today. So other questions that I can react to?
Yes. Beside these entrepreneurial things, excess of technology, like how emerging economy actually can get more access in this kind of technology, that is important. And when I work in the grassroots level, I find uh, awareness, capacity building, awareness campaign, capacity building, this is the major challenges. So how this kind of corporations or innovator, technology innovator can engage more with this kind of activities to educate emerging economy people?
Well, that's a lot of questions there. Um, the first part is the training to use 3D maps, and is very widely available on the internet. I can pull up, and I just did a search on it a minute ago, hundreds of courses on how to use it for different apps. Also, if you begin to look at open source software, um, there's a lot of them. The top 50 open source 3D modeling for geospatial is there. Then you see, for example, an open source software called Wings 3D, which is designed for governments and urban planners to use to plan subdivisions. And there's 8 other open sources for that. Um, there's open source 3D mapping for manufacturing, uh, open source 3D mapping for transportation, um, and just going down through it. Boy, I'm surprised on this one. There's a lot of open source software for drone mapping there, and just beginning to put the elements together. Uh, you're seeing that the open source community is there. And for entrepreneurs, that's how you want to get started first. You want to use the software that's free and open source. Now, you have to be very careful to read the licenses. I give you an example. We were using some open source software and out of one of the California universities here in the United States, um, in healthcare. But when you went back and read the open source license, it says it was free to use except in industries that did animal testing. Well, guess what? Healthcare that uses animal testing. So that software was not an open source software we could use there, and we had to substitute it. But for your entrepreneurs, I would start with open source and look at how it can be used. There's so many 3D mapping as a service sites on the internet that you can use those resources without having to buy the software to install on your devices. And you can use those public services. The two examples I shared during this are both free resources that I brought up to show you different parts of the world and to show you how it can be used. And, I didn't choose one of my cities here in the United States. I went to Bangladesh, I went to Brazil, and brought uh, sites up there to just show you and your audience, Sharif, how easy it is to use in the developing nation, not just the developed nation. And these were free resources that we brought up in real time to use as examples for your audience. The other thing is the use of this digitalization is continuing the trend. The next place you're going to see where 3D mapping is going to go, and I'm going to use 4D because it's going to have time change to it, is as we apply the Internet of Things sensors to it. So let me take the 3D mapping, put it on a street, and be able to judge traffic in real time going through it with the sensors. Let me go and do a map of a lake using 3D mapping to see what are the temperature differences at the surface. What's the temperature 3 meters under the water? And be able to create maps like that. In a manufacturing environment, combine it with sensors and be able to not only see the 3D mapping, but tie it into the factory automation system where the inventory gets shown in real time through the integration of the Internet of Things and the 3D, 4D mapping that you can do there. So you can see as you begin to look at the integration because you're in the digital world, and that we can take these digital worlds and have them interop with others, most likely through platforms. The possibilities are pretty endless for existing companies, for entrepreneurs, for the government. And because so much of this technology is either free and open source or low cost, the barriers for entry for a developing nation or a developed nation are very low. That, and particularly for a uh, developing nation, the ability to use it on the servers on the web, like Google Earth is run off of Google's servers in their data center, where the heavy compute, the heavy storage, the heavy imaging, the satellite images and refreshes are done there. So it makes the cost factors and the very low for the entrepreneurs in the developing nation. Um, so I think with your question of the entrepreneurship there, Sharif, this is a tool that they should become available with. And we need to see this taught more and more in boot camps where it can be applied, more in special sessions of where you can begin to use this technology. I was at a meeting last night here in Austin, Texas, with the Austin Forum, and the session was about how do you use 3D virtual reality in the next generation of the world, and great presentations. And it all is built on the same model like we have here, is how do we take this and how do we apply it going forward to have a good result. Um, and so it's a topic everywhere. Like I said, it was on the topic at our Austin Technology Forum last night. So, Sharif, I think it works anywhere in the world. And it's just you need to have the ability to search, find the resources, apply your use cases to it, and see if it works well in your use case. And then actually do internet searches around your use case with 3D mapping to see if you can find the best practices. And I think in most applications, you'll be able to do that. So I hope this has helped, Sharif.
Thank you, Professor. This is really, really helpful session because this kind of critical uh, topic is not familiar for developing nations. And you know that we are engaging with many education institutions. We are helping many entrepreneurs. We are helping many youth. So your knowledge and expertise is priceless for us. And definitely we want to see you uh, in India or in Bangladesh soon, because hopefully your class will be more productive. Your practical experience and expertise will be more helpful
Would
for
love to come over
emerging
for the
economic
Tesla
development.
conference.
Yes,
Yes.
thank you. Thank you, Professor David Smith. And what's your concluding remarks today's session? And I want to give you very, very, very special thanks for this excellent session.
My concluding remarks really are pretty simple, is that these are some of the technology tools that you can begin to use in so many different ways and in so many different elements. Your access to resources are really fantastic. Don't think of 3D mapping just as a visual tool. Think about how you can use 3D mapping, like the Excel 3D mapping, to look at your data in different ways, to gain new insights to your data. I can tell you when I take some data that I think I understand looking at a histogram in 2D and change that histogram to 3Ds and see how steep a rise were or a fall off of data from one source to the next. It gives you a new appreciation for the changes in your data that just looking at a spreadsheet does not give me. Um, but my biggest concluding remark on it, Sharif, is there's so many resources out there, and particularly for a developing nation, is go try some of the stuff online. Go and see how it can be used for you. Go and examine what is free. And there's just so much free that you can do a lot with before you have to spend money to make a purchase, if you have to spend money to make a purchase at all. Um, and there's the old saying, just do it. And 3D and 4D mapping really is the future with all the autonomous vehicles, the autonomous manufacturing, the autonomous agriculture, it being applied to retail. This is going to touch most places. So learn it, dream about what you want to do with it, look at the tools which are there to create your dream, and then start putting a plan in place to go and meet the needs of where your dream can solve the problems for your customers. And that's really, Sharif, I think my concluding remarks.
Thank you, Professor, for your excellent sessions. I request all of our audience, please share our content with your government agency, corporation, and academy. World Talent Economy Forum closely work with government agency, academy, as well as with the industry, and we are developing more industrial research and industrial innovations. Uh, Beside this dialogue, we take a lot of practical actions. We develop a lot of projects. So from our speaker, from our audience, those who want to join with World Talent Economy Forum as a member, as a contributor, you can join. Thank you everyone for joining today's session, and I want to give special thanks to Professor David Smith for your continuous support to World Talent Economy Forum. Thank you, bye bye, and take care.
Thank you.